Hi, my name is Filip. Today I will show you how to use this 2.9-inch E-Ink display made by Waveshare together with STM32. I will show you how to port the official library, how to interface your display with a Nucleo board. I will tell you a few words about my Linux STM32 development setup. So let's get started. So for programming STM32 I use VS Code with official STM32 Cube extension. I don't use standalone STM32 Cube IDE. However, I use STM32 Cube MX. So if you want to create your project from scratch using VS Code, you need to first install a few dependencies. And those dependencies are CMake and ST-Link tools. You need to have STM32 Cube MX installed too. So I've got all this stuff installed already, so I can create a new project. So let's do it. First I need to launch STM32 Cube MX. Yeah, it opened. Oh, my board is actually Nucleo C031C6. And this board is barely able to run this display, and I don't recommend it for more complex projects. We don't need any demonstration code, we don't need any options selected here as well. We just want to create empty project with minimal configuration, and it will be a CMake project because it will allow us to actually use VS Code in our workflow. So let's save it first. Okay, so we need to enable hardware SPI to be able to communicate with our display. Let's use transmit only master because we don't need to read any data from our display. We just write it here. We don't need hardware NSS signal. Frame format Motorola is okay. Data size 8 bits, most significant byte first. And we don't need that much speed actually, so this display works well if you use slower SPI like 3 megabits per second because it's slow anyway. Communication with it's not bottleneck really. We need to assign additional pins for our display: BZ, RST, DC and CS. We can't just send data from our MCU to this display and hope for the best. We need to check BZ flag first, and this pin will allow us to do so. It needs to be input, actually, GPIO input, and let's change its name to something normal. So we set it to input mode, no pull up, no pull down, and our label will be just busy. It will be our RST pin. We set output level, default output level to any value we want. We'll change it anyway. GPIO mode is okay, pull up, pull down okay, and label is RST. So the same story goes for DC pin, yeah, and CS. I will actually replace CS with RST because that's how I connected this display recently, so I don't need to change any cables. Before generating the project, let's check clock configuration. Yeah, it's default configuration, it's enough. And we need to change our toolchain to CMake. And our application structure should be advanced because, you know, if you choose basic project structure, header files and source files will be mixed, and I don't recommend it. So just stick to advanced. Okay, so we are ready to generate code. So we can now minimize it and open it in STM32 Cube IDE. I can see that our boilerplate project was generated. So now we need to set it up inside VS Code. Okay, it needs to be configured. No problem. Okay, so let's start building our fresh project. It should build without errors because, you know, it's just empty project. We haven't really changed anything. And yeah, as you can see, it built successfully. I started debugger and I can run main program, which does nothing actually. But I can see that communication with the board is okay and it compiles correctly. So we can go straight to porting our library actually. Okay, so in order to download this library, we need to go to Waveshare website, go to wiki, choose our 2.9-inch e-paper module. Specific version doesn't really matter here. We will configure it later. I will show you how. Okay, let's go to working with STM32. Because we need to actually download existing project, demo project, and extract library from there. It's somehow counterintuitive, but we'll figure it out. Trust me. Okay, I can extract it here. We can see here is STM32 folder. We go there. Oh, so I see this project was created for Blue Pill, I think. F103. Okay, and it's a project made in Kyle Microvision, and we don't actually need those files like drivers because it contains some whole and stuff. Include doesn't really matter for us. Same story with SRC, but this folder, this folder is actually really important because it contains the code of this library. There is some readme, examples, fonts, stuff. So what we need actually, what is the purpose of all those folders? So this folder config contains two important files, devconfig.c, devconfig.h, and here is hardware abstraction layer. So those files basically contain wrappers for method specific for our whole. So it makes the library portable. We will have to replace them. I will show you how. Okay. GUI paint.c and .h are graphics drawing layer actually, and in this folder e-paper we can find a specific screen driver. It needs to match our version. Yeah, we need to find a version of our display in order to locate correct driver. So when you take this board, and you can see this small sticker here, V4, and my display comes with 3-color version. There is also 2-color version, very popular, black and white, and my version is black, red, white. Yeah. So why I need this information? Because if the name of this file contains B, it means it's actually 3-color version. So I need to choose file EPD 2in9 because the dimension of my display BV4. So and I'm good. Okay, let's go back. When it comes to fonts, we don't need to load every single font file to our project, because if you won't use it, it will just consume your flash memory, and it won't be beneficial in a way. So if you just use font 16 and 20 and you don't need Chinese font, just choose 2 files and you are good. So let's move them actually. I will split my editor and go to my project location. Oh, it's this one. And I need to open core folder, files to the folder. So let's say I just want to use font 16, maybe font 20. Let's copy it, and it will be, oh, those are actually source files, so let's move it here. You know, in real life project you should create separate folder for all the library files, but you know, my project won't do anything except driving this display, so I think I will leave it as it is. All right. Oh. Yeah, don't forget about header file. Cool. We need both files from GUI actually. Okay. I want to move back here, not there. We don't need examples, I will delete it. Yeah, from ePaper I need to find my driver. It was like, oh, this one. And let's move to config folder. Okay. Okay, enough copying and pasting, let's go to coding. Yeah. Before writing single line of code, we need to make sure that our library files will be actually included in our CMake list txt file, because we need to explicitly tell CMake to include those files, otherwise they will be skipped and you will get big loads of errors everywhere during compilation. We want to avoid that. Let's see if our project built. Oh, it actually exits with code 1, but why? We need to... Yeah, we need to investigate what's the cause actually. Ah, I think I see. So let's go to this devconfig.c file. And okay, so here is our culprit, this line 33, because it includes STM32 F1 series whole library. Of course, we don't need such library in our project. We can just delete this line, and we should include main.h file, because it already contains a reference to other library which contains our whole methods. They will be used here for transmitting, receiving data anyway. Okay, so let's see if it builds now. Nah, still no luck. Why? Ah, because in devconfig.h is Same story. And it means we can actually delete main.h from our file because it will be included through this header file anyway. What's wrong there? I don't know, maybe it's false positive. Let's try building it. Ooh, it's a lot to unpack here. I think we don't need this debug. We need to fix it. So let's open dev-config.h and see what happens. Okay, I know what's the reason. So, do you remember assigning meaningful names during STM32Cube MX project generation? Well, that's when we need to actually use them. So, my RST pin is named, guess what? RST pin. I did it by purpose to make my life easier. So let's see what other pins we need to assign here. RST pin, DC pin, and here is power pin. And the thing with power pin is it's not used here. It's not even present of this board. So why do we use it? Because, well, other versions of this Waveshare displays utilize this pin. So in this case we just need to make the compiler happy, so let's assign any unused GPIO there, and I think we can go with GPIO A. And pin 0 is okay. Okay, so this part is fixed. Let's move to another one. Something is wrong with GUI paint, and it shows that path to this fonts file is wrong. Yeah, I see. It really is, because we need to reference it from the same folder. So just remove everything, and it should work. Okay, something is wrong in this. In our driver file, I know what, because I commented out this. I commented out this debug file because I don't include it, and so we need to remove or comment out any debug methods. Okay, I don't see any more occurrences, so we can leave it as it is, I think. Let's try again. Oh. I see. The problem is it's actually included somewhere else. But where? Here. Okay, so after commenting out every method occurrence, it shows some warnings regarding multi-line comments. I'm not gonna fix it actually. So let's move to dev-config.c file and modify it a little bit. So we can leave this method empty because first, we don't need it actually. Second, we don't want to mess up with CubeMX GPIO configuration. So let's delete it, leave it as it is. Okay. Oh, that's actually surprising. You know, I haven't really seen SPI communication done by bit banging for a really long time, but it's unnecessary actually. We can use something like whole transmit. It will go like this. Whole SPI transmit, yeah, and we need to specify here. We need to reference data passed as argument. Size it will be 1, and timeout, let's give it 1 second. It should be good. When it comes to reading data, we don't actually need any method for that, because we simply don't read any data. Okay, when it comes to module init, we need to just comment out this line containing power pin. Alright, so now we should be able to test our display. Let's do it. We need to move to main.c file and write some test code. But first we need to create image buffer. So let's do it. It should have type ubyte, and let's name it black image, and it has size of 4736 bytes. Yeah, and we need separate buffer for red image if we use multicolor display. Okay. And now we can go to our main method. After initializing peripherals, we can write something to our display. So let's initialize it first by using method dev module init method and initialize our display. And we can clear it. Okay, give it some delay. It doesn't actually really matter if we use whole delay or this method, because this method actually calls whole delay underneath the hood anyway. Okay, so let's paint it. In order to paint something, we need to actually create image. So let's do it. And we need separate images for black and red color, actually. That's why I created two buffers. Our display dimensions are stored inside two constants, so we can utilize them. We need to rotate it 270 degrees. If we skip it, our image will be reversed. We don't want that. Yeah, and color should be white. I will actually close this one. We don't need it anymore. It should be uppercase. So let's copy it. Yeah, and the same story goes for red image. All right. So first I want to paint my image white, and then I will paint some rectangles and stuff. So let's do it. Okay, and I need to repeat this operation for a second image. And let's say I want to paint some rectangle using black image, so I select image first. And now I can paint my rectangle. It can start, I don't know. Those are completely random coordinates. I don't really know what will happen here, but we'll see. Oh, this L is unnecessary. I don't know if it's correct because IDE doesn't highlight it. Yeah, it's correct. Okay. And it can be empty. And I want to add some text with using red color, because why not? There is separate method for drawing English and Chinese string, by the way. You can see something interesting here because I chose a color foreground on my red image and I set it to black. But why? Well, the thing is, in this library, red is mapped to black anyway, and it doesn't actually matter if you choose black or red, it will render correctly. Selecting proper image is more important actually. Okay, so let's see if my project will build. Well, not really, but why? So here is the typo, I think. Yeah, it is. It should be with. Okay, now it should build correctly. Yeah, it really does. Okay, so now I'm gonna upload this code to my board and let's see what happens. Great, our display works. And it's really cool because, you know, view angle is great. It's like with real paper, you know. And the good thing is this display remains in the last state after disconnecting power. I hope you enjoyed this clip and see you next time. Bye!